America. This is Atomic TV, and I am Mohit Lester, Mo for short, and this is my co-anchor, Just In Case. And before we commence today, we have an urgent message from police authorities. Criminal mastermind Robin Banks has escaped from Guantanamo Bay after serving a 4-year sentence. Police cameras caught him on scene, but unfortunately, he was unable to be caught.
Police authorities have told us that Robin Banks has threatened to blow up Central Park, but there's no evidence of this. Bomb squad is already on the way, but they haven't detected anything yet.
You will be informed of any serious updates as soon as possible. Anyway, in today's newscast, we will be investigating the periodic table. A periodic table is like a map with numerous keys, such as ionization energy, periods, groups, etc., etc. What is that you say? Don't worry, we'll cover them all in this newscast.
Urgent update. Robin Banks has left some clues. He said, first letter 1s2, 2s2, 2p6, 3s2, 3p5 equals upside down y times v equals 0.17. Find specific colored paper. I don't understand this.
You know anyone who understands this stuff?
My good friend Dr. Iyer should know about this.
Oh, Dr. Jayashuri Atapattu Sivama Krishna Radha Shekara Srinivasana Trichipalli Yeke Param Pila Paramadhuda Chinda Swami Muthu Swami Venu Gopal Iyer?
Yeah, you know him?
Yeah, let's do it.
Alright.
Hello Data, how are you?
Good. Hi, hello Dr. Iyer.
Please call me Venugopal.
Okay. Sit down.
Now here this is a periodic table. It was created by Timothy Mendeleev, who left the empty spaces for future elements, who already predicted the properties for. If you see that this is alkaline and this is alkaline metal, this is alkaline earth, lanthanide series, actinide series, noble gas, halogens. Before I move on, let me call my brother who visiting from India. Papu?
Hi, Papu.
Hi.
Alright, so based off the periodic table, the S is located under the 1A and 2A, so this and this. Helium is supposed to be there. That's what I learned in high school. Isn't there something else? So wait, the P. The P is located under the last 6, so I'm guessing the non-metals, I believe. These are non-metals, right? I'm not sure. Yeah, these are the metals, so this must be non-metals.
Yeah.
Alkaline. I think Dr. Iyer told me something about that. So is that it? Wait, I think there's more.
Yeah, there's also a D group and an F group. The D group is found in the set of transition metals right here, and the F group is on the bottom of the periodic table.
Oh, so if you count each one of these, it adds up. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, that makes sense. All right.
Yeah, and also, but there's one thing different. When you're working with d orbitals, the coefficient is always n minus 1. So for example, this row would be 1, 2, the fourth row, right? But since it's n minus 1, when you put the coefficient out, that should be 3. And for the F group, it would be n minus 2. So.
Alright, thanks. I also learned something about electron configuration, but Dr. Iyer did not mention that. Define, if I remember from high school, define the electron configuration of, say, iron, which is atomic number of 26.
Yeah.
So 26. So this means it has 26 electrons. So 26 electrons. The electron configuration is like a map. So here's the 1s2, 1s2. Now here's a 2s2, so 1, 2. So we have 1s2, then 2s2. Now we have the 6 for the p, so 2p6. Then we have the 3s2, 3s2. Then the 3p6. But then the 4s2 has a slightly lower energy than 3d10. So 4s2 comes first. So 3p6, 4s2. But now we're at here. And we don't go all the way 3d10, so 1, 2, 3, 4, 5, 6. So that's, what would that be? 3d6. So
Yeah.
the electron configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So to check our work, we can add up the charges: 4, 10, 12, 18, 20 equals 26, 26, 26, check.
Yeah, looks like you know a lot.
According to my high school teacher, there were some exceptions. Do you know any of those, Papu?
Yeah, there are some exceptions. For example, there's copper right here. If you did the normal electron configuration, the ending would be 3d9. and but that doesn't work like that because a complete 3D orbital is more stable. So what happens is actually the 4s2 electron is promoted to a 3D electron. So it actually becomes 4s1 3d10.
Oh, okay, alright.
Yeah. Alright folks, Adam Baum here filling in for Mo. Sorry, he had an appointment but he couldn't make it, but we finally figured out the first clue. Using electron configuration, we found out that chlorine is the answer. Everything else, we have no idea.
Adam, one of my friends is a physicist, and I've seen him working with this upside down Y thing before. Let me give him a call.
Hello, Peter Chow here.
Oops, wrong number. Alright, 7546.
Mikhail, this is Vladimir. What did you do with the body?
Hello, this is Justin Case from Atomic TV.
Yes,
Hello?
okay, what do you want? I'm sorry, I was expecting a call.
I was wondering if you could explain to me wavelength, frequency, and energy of a photon, please?
Okay, basically by 1900, physicists had determined that light travels through waves. The amplitude of a wave is the wave's height from zero to crest. The wavelength is represented by the upside down Y, which is the Greek letter lambda. It is the distance between the crests. The frequency is represented by V, the Greek letter nu. And it's the number of wave cycles to pass a given point per unit of time. The product of frequency and wavelength always equals the constant c, which is the speed of light. In other words, the wavelength and frequency of light are inversely proportional to each other. As the wavelength of light increases, for example, the frequency decreases.
Okay, thanks a lot. You helped us a lot. Thanks a lot. This is what Robin Banks' next clue meant. The first letter of chlorine is C, and C equals lambda nu. And if V equals 0.17, then I can find lambda. Oh wait, I still need C. Chlorine has an atomic number of 17, so it must have 17 electrons, right?
Yeah.
According to what he explained to us. Maybe that's the hint. Alright, so 17 divided by 0.17, what is that? That's 100. Now it asked me to find a piece of colored paper. And if I remembered I did chemistry in 9th grade, so what does 100 have to do with paper?
How wavelength?
Yeah, oh wait, wavelength corresponds to the color. And if I remember, wavelength of 100 M corresponds to the color red, if I remember that. Do you think I'm right? Check
Yeah,
out
can we get a
everything.
book over here?
I think so. Wavelength does correspond to the... Thank you. Yeah, wavelength corresponds to the color red. Alright, so is that it? What's next? Before we find out, we'll be right back.
You want to be invisible, or scare your friends, or even stalk them. Well, now you can with the Invisibility Cloak 5000. So, Veer, can you help me with cations and anions?
No, wait. Before I answer your question, I have a question for you.
What's that?
On a scale of dumb to dumb, how smart do you think you are?
You know what? I think I'm gonna go with pretty dumb.
You know what? You're probably right.
Alright then.
Yeah. Alright, so basically, these are the top of the groups, and it shows the group number. And for groups 1A through 8A, this is the same as the number of electrons in the valence shell. To find the charge, subtract the number of valence electrons from 8 if the number of valence electrons is more than 4.
Alright.
If it's less than 4, it is the same as the charge it already has. Polyatomic ions have many atoms, but they still have a charge other than 0. And monoatomic ions have only one atom.
Alright, that really clears things up. Thank you, Veer. Hello, this is Budweiser from Atomic TV.
Can I help you?
Yeah, I just want to know I needed help with naming compounds and acids.
I can help you. Are you friends of yours?
Yes, I am.
Okay, of course. Come on in.
Right here. Have a seat over here.
Okay, so for example, the question you might get is calcium plus chlorine equals what? So what you need to know about the ionic bonding, to name any binary ionic compound, first place the cation name first, and followed by the anion name. For example, one would be CS2O, for example. This is cesium oxide. However, if it were copper oxide, it could be written as two formulas. This is since copper takes two forms of cations, copper 1 and copper 2. Switching formulas, you should get either CuO or CuO2. Add subscripts to balance the charges. For example, iron 2 oxide 3. This is Fe plus 3. You understand? So in order to check to see if the balances are charges, you write the check. And then 2, because the subscript 3 plus 3, and then 2 minus. For the other charge equals 0, and 0 is a balanced charge, so you know it can make the ionic compound which is balanced and it comes together perfectly. Thank you very much.
So what exactly are we looking for? I don't know, a bomb of some sort. I don't know. What kind of person would sell a bomb around here?
I don't know, an Arab?
Hey, no racism. This is live TV.
I'm sorry.
Hey!
Wait,
Weird, guys. Check it out. Check it out.
Can I touch it?
looks like a bomb calorimeter.
Yeah, I saw that in the book.
Robin Banks bomb calorimeter. Is that what he meant by a bomb?
Look what it says. Look what it says inside.
1,3 dimethyl.
That's exactly what that clue said.
That's weird.
Wait, who's that? I think I see him. We got him!
Let me use the gas, dude!
Get him!
I'm gonna interrogate you.
You're gonna be sorry.
So why'd you use red? We're able to calculate the bomb calorimeter using the equation C equals lambda times nu, where lambda represents wavelength.
That word tells the truth.
And nu represents frequency. To use that equation, and then you look at the atomic spectra, your answer will be equivalent to that of red.
Alright, welcome back to Atomic TV. I'm Mohit Lester again. I'm back from my meeting with the correspondent.
Okay, so we have finally reached a conclusion. The bomb Robin Banks was talking about was actually a bomb calorimeter. What to do now? The only thing we know is that inside the bomb calorimeter there was a piece of paper that had a writing called 1,3 dimethylhexane. I don't know what that is. Whatever that is.
Alright, well, thanks for watching. And please tune in later this week for an update on the Robin Banks chase. See you later.
This is Justin Case and Mo Lester bidding you adieu.
Robin Banks Jr., you are now sentenced to 4 years in prison.
You're never gonna become a news anchor ever again.
Without parole.
In 4 years, I'm gonna be back in the business on top. In 4 years, y'all gonna be giving me props.
Alright, you enjoy your time then.